That's a good way to put it. It takes time. Things take time. And it takes time to get good at something. So, yeah, I could do things now that I could do 10 years ago. When I look at somebody brings a video problem to me, I could suggest solutions that I just it wouldn't have been possible even 10 years ago, right?
Wow.
With the breadth of experience that you have over the years. Patience, important. I this kind of stubbornness. I remember my supervisor, my PhD supervisor, in my second year. No, at the end of my first year PhD, he told me, Kokaram, your math's horrible. You better fix it. And he was right, The thing is, I just couldn't get motivated by mathematics, right? What motivated me is sort of the application. What you're trying to do, and then you get kind of absorbed in the solution, and then you find this crazy little bit of mathematics that you then go and you spin out or fix or something, right? And then I really started to take that bit of what I was missing more seriously, right? Because at that time, I used to be frustrated that I couldn't, I wasn't good enough to figure out some of these more tricky mathematical models. And then I just had to have the patience to spend time. Like I tell my own students, just take the paper, which is portrait, turn it landscape, write every single thing out, right? Don't skip a step, just write it out. That helped me a lot. So just having the patience, don't mind being slow over things, just get to the end eventually. That, to me, that's important.
Understood.
Another thing that's important over the years I realized is, pay attention to people, pay attention to people. Everybody has some contribution to make. Leave yourself open to opportunities.
Today, my guest is Professor Anil Kokaram. He graduated in 1993 with a PhD in signal processing from the Cambridge University Engineering Department in the UK. He is now a professor and chair of electronics at Trinity College Dublin in Ireland. From 2011 to 2017, he was the lead of the media algorithms team at YouTube and Google. Before that, he founded a media digital signal processing group at Trinity College Dublin, working in the broad areas of digital signal processing for video processing, Bayesian Inference, and motion estimation. He has published over 200 reference papers in these areas. That's a lot. He was a former associate editor of IEEE Transactions on video technology and IEEE Transactions on image processing, and currently serves as a senior area editor. He was the founder of a company called GreenParrotPictures, producing video enhancement software that was acquired by Google in 2011. In 2007, he was honored with a Science and Engineering Academy Award from the American Academy of Motion Picture Arts and Sciences for his work in video processing and post-production applications. It's definitely an honor for us to have Professor Kokaram on the podcast today. You might hear a little bit of background noise as we go along, so just bear with us and enjoy the interview. There we go.
The show where we talk about data science in the Caribbean, highlighting practical ways that you can learn, get involved, and create your own impact using artificial intelligence and machine learning. This is the Caribbean Data Science Podcast with Mark Moyu and Jeff Sayon.
Professor Kokaram, thank you very much for joining us on the show today.
Thanks very much, Mark. Glad to be invited. Glad to participate in your series.
Wonderful. So why don't you kind of tell us where you live at the moment and what you're currently working on?
So right now, I live in Dublin. I am a professor of electrical engineering and head of department of electronics in Trinity College Dublin. In the engineering school here. Right now, just splitting my time between running the department, which is everything, and continuing work in video processing, a bit of work on sports, a bit of work on video compression, and so on. Yeah.
Okay, great. So since 2004, right? You've been kind of pioneering machine learning advancements for consumer video applications. So can you give us an example of something we take for granted today that you've kind of worked on behind the scenes?
A couple of interesting examples. So in a long time ago, in the late 90s, I used to work in restoration and restoring old movies. And because of the people I was working with, I worked with the post-production industry at the time. A couple of guys, Bill Collis and Simon Robinson, they got me involved in doing some sort of motion estimation work for episodes, which were eventually used for episodes of The Matrix. So
Nice.
the in-betweening stuff that you see anytime, there's a kind of popular tool in post-production software called Nuke, and that tool is used for building frames in between existing frames. And somewhere inside there's a bit of mathematics that I did. And yeah, that's the thing that we won this big award for back in 2007. But the other interesting thing is something people use every day and they don't notice. So in YouTube now, so I joined YouTube back in 2011, about 6 years, and during that time we put a sort of enhancement module inside the YouTube upload pipeline. So every time your video gets popular, this module tries to reduce noise, among other things, and that improves the bandwidth and quality and so on. And so it's funny, everybody uses that every day and they don't notice, which is probably a good thing. Yeah.
That's fantastic. So that means more people can watch, that particular video as it gets more and more popular on the same sort of infrastructure.
So the infrastructure is better able to handle that sort of video. It shaves a few percentage points off the bitrate of the video, so it'll fit down narrower pipes and still look good.
Yes. And I don't think many people probably think about that on a daily basis. Oh, what infrastructure does it take to serve videos across the world, right?
Yeah, exactly. We can spend a lot of time talking about that. It's not for nothing that companies like YouTube and Netflix, their engineering teams, paved the way there in around 2006, and then later on showing the world that you can use the internet as a viable alternative broadcast infrastructure compared to satellite and terrestrial broadcast television. And that opened up a whole other political can of worms, right?
Yes.
About access to broadband internet and the treatment of all applications as the same or not, and so on. And so those companies eventually caused this term over the top, right? Meaning that they were able to broadcast television sort of into your home without going through your traditional television or satellite infrastructure. So you're paying for broadband, and suddenly now you have this whole access to television infrastructure without having to pay the cable network for cable or the satellite network for satellite. So you can see, 2006 to 2008, 9, interesting time for the world at that time.
Yeah, and I take that for granted, right? I don't have any cable, and all you just watch is YouTube or any other type of streaming service. So that's quite exciting that someone from the Caribbean has worked on that type of infrastructure that is serving a lot of people around the world.
Yeah, and the amount of engineering expertise it takes to do that, you can't underestimate the layers of infrastructure involved, from hardware processing all the way to software in your browser, and in collaboration with the mobile phone networks. So all these big companies started to negotiate with the mobile phone companies to put caches in different areas so that
I see.
Content, faster. The more downloaded content in your region moves closer to you, if you like. A lot of different technologies come together to make that happen. I mean, you have to understand, even what we're doing here, the internet was not made to do this, right? The internet was made to send short email messages, and it was made to send short email messages, throw away comments, and keep people in touch. It wasn't made to broadcast video and disrupt an entire industry, right?
No way. I would have not thought that at all.
Yeah, there you go. That's all. Well, that's engineering, right? Taking a sort of concept and adding layers to make it
better,
stand this test of time, right? Yeah,
absolutely. So you are a professor at Trinity College Dublin. You're running the department there. Why did you kind of choose to work there, and we'll kind of dive into your career story? I know you probably, I think you did your postdoc there, I believe, if I'm...
my postdoc in Cambridge.
In Cambridge, you did in Cambridge. Okay, cool.
Yeah, well, I suppose I could give you a potted history. I mean, I did my secondary school. Well, we could even go further back.
Yeah.
So primary school was Trinity Presbyterian.
I went there.
You went there?
Right?
Yeah. Then I went to Hillview College for secondary school, 86. Graduated in 85, 86. I spent a year teaching in Hillview, education itself. And then 86 went to Cambridge to do undergraduate. At the time, that degree was called Electronic and Information Engineering. And that actually is interesting by itself, right? Because it's both information engineering and electronics in this degree. It was only a 3-year degree. After that, I did my PhD up till around 1993, and then stayed there to do postdoc. In the last year, I think I was a fellow at Churchill College or something like that, and then moved here in 98, went to Trinity in Dublin. And well, the reason why, by the time I started to get involved in research as a postdoc and so on, I knew that I wanted to do research, and I liked teaching. So it seemed a natural choice to look around for academic career. And, it's tricky to find open positions at that time. Right. Trinity College, a lot of my friends happened to be Irish at the time for some reason. And I found out about Trinity College Dublin, and it seemed to be great. I came over here. I was surprised I was able to play cricket. And
fantastic.
It was a good call, yeah. So what is interesting, though, in 98, so if you were interested in research and academic research and so on, in 97, 98, the world was changing. Up to that point, you only a few companies had big research labs, right? So you had IBM research, you had AT&T or Lucent research, but not a lot else, right? Then around that time, Microsoft launched Microsoft Research Labs, and they had a research lab in Seattle, and they put one in Cambridge. And then it seemed, since then, there's a lot more opportunities to do research in industry than there used to be, right?
Yes.
So NVIDIA have a big research group, Google. So and the list goes on. Samsung, Sony, of course, BBC, R&D, been around for a long, long time. So the environment now is a lot different than it was back in the late 90s. And if you want to do research, the academic track is no longer just the one track you could go, right? A lot of different tracks. So the one thing about the academic track, which I find interesting still, is the different things that I could do, right? So
I see.
In the morning, I could be talking to people on a project to stream cricket more efficiently. And in the afternoon, talking to some guys in biology about counting birds or detecting bird song or something, right? And you couldn't do that if you were, in any particular company, right?
In a hardcore, company research lab, you gotta make some products work, right? And probably the pressure. Do you think the pressure to publish there is more than the pressure to publish in traditional academia?
No, I mean, the pressure to publish in academia now is probably higher than it ever was.
Wow. Okay.
So
That's good for everybody to know as well.
Publishing is really important. And life in our research lab in some of these big corporations is, there's a lot of similarity with life in a university,
Mm-hmm.
but the focus is different, right? In university, it's almost like every academic is a little startup on its own, doing financial management and training and, and research all in the same brain. Whereas in a research lab, you don't have to worry too much about the financial management.
Okay.
Maybe you have to do a little training, so you can spend a lot of time doing focus. But the emphasis might be a little different, but the loads, that publishing is something that is same in
The pressure.
academia. Yeah, the pressure. Yeah.
Mm-hmm.
So I suppose in academia, you have these two pressures of teaching and research. And in research, you have to be publishing. In our research lab, you have to be doing research that seems relevant and at the same time being in touch with new things, which means publishing and so on.
Right.
So,
like grant money and all that type of stuff that you have to bring in.
Yeah, grant money in academia, I spend all the time applying for grants, right?
Mm-hmm.
While I was working in YouTube, I didn't miss that.
Yeah. I could imagine. So we do the show to encourage people from the Caribbean region to pursue what I'm going to call a data-driven career, right? And what that simply means is, being part of the new ecosystem of be it data engineering, data science, machine learning, anything to do with products and services that drive the economy forward through those mechanisms. So can you share with us your view on how you think machine learning, AI, and tech will actually play a role in the Caribbean's future?
Well, okay, there's a big question there. I mean, tech has to play a big role in any
future.
economy, any future, right? AI and machine learning, I don't like to use the word AI. It has a lot of connotations that still are wrong, right? Machine learning is probably a better word. And in the Caribbean region, the funny thing is that if you look at the parts of the world that sort of develop a big reputation for technology and so on, a lot of these parts of the world also, one of the first reasons that people went to those parts of the world is because they're good places to live, right? California, for one obvious example, right?
Yes.
So the Caribbean has that going for it, but somehow never quite managed to exploit all the brain power being produced there, right? The school system there actually still quite good. And I would think that the Caribbean could make more of its natural talent, both in terms of climate as well as people, right?
Yes.
And as far as playing a part in the future, the funny thing people don't realize, technology is a labor-intensive business, right? You got a lot of, when it comes to product design and so on, a lot of people get involved to build infrastructure. You have a few thousand engineers in YouTube trying to put together video and infrastructure and software systems and so on. So, some people look at tech and say, oh, well, the entire, like an example is the whole travel industry gets, what do you call it, the travel agent industry. So they get wiped out by online travel booking and so on, right? But you could say that. On the other hand, there's a lot of people it takes to do a good travel infrastructure website and maintain it and all the rest of it. So, like, I would think that it should play a bigger role, right? Actually, I find it's a more labor-intensive process to create products in this space than people give it credit for. Probably because the products that you tend to work on, people think replace jobs or something. So reduce the number of people doing A, B, and C, right? So yeah, it should play. It should play a part in the future of the Caribbean, certainly for job creation. Yeah, Exactly how, I mean, agri-science, at one point the University of West Indies was, what was the Imperial College of Tropical Agriculture, one of the best places in the world to
Really?
study tropical agriculture. Yeah, and
Wow.
yeah, why couldn't it become something like that again for agri-science?
Mm-hmm. Yeah, and
Like,
agri-science has so much machine learning in it now, right?
yeah, satellite inference from satellite, inference from sensor measurements distributed over your farmland. The West Indies also, pretty good communications infrastructure now because there was sort of nothing many years ago, and then um, more people are connected to fiber in the West Indies than here. I mean, so I just moved to a new place, which is about 2 miles away from where I was living, and I don't have fiber. My bit rate is 7.5 megabits per second over copper ADSL. And the Irish government here is still trying to get people connected to fiber, right? So yeah, the infrastructure is there in the West Indies for people to exploit technology, and I think there's more to people just don't give the credit for that labor intensive part of the product generation process.
Yeah, I like that you brought that up, and I even didn't necessarily focus on, okay, you might, like you say, replace travel agents, but the travel booking website will have, a couple dozen, maybe a couple hundred, depending on the suite of products that you create, and they'll be getting paid way more than a travel agent, right? To
Yeah,
some degree.
yeah. There's a good there's a kind of what's the word there? Missing. So missing joined up thinking there when it comes to exploiting that in the Caribbean.
Understood. So before we dive into how you ended up selling your company, GreenParrotPictures, to Google in 2011, you kind of gave us a flavor of your career journey so far. You grew up in Trinidad. You went to high school in Cura Press. You went to Hillview College. And I think I was doing some reading that you did math, physics, and chemistry, right? In high school. Did you kind of always know what you wanted to do when you were in high school, or you just you did say there that you're super curious in your bio in one of your wiki pages, but kind of share with us there. And the main reason for that is, I'll tell you my own example. I have no clue what the hell I want to do. Okay. And when I was back then, I was just like, I don't want to go to school. That was my attitude. So
Yeah.
I'd be completely different to yours, right?
Yeah, no, I didn't like primary school that much. I don't know why. I remember I liked secondary school more. Did I always know? Somehow, well, I know by the time I finished secondary school, I wanted to do research of some kind.
Wow.
And I think I get that idea because I was just interested in building stuff and just arbitrarily trying out new things. I was interested, in model aircraft and model rockets. And I suppose most people are happy enough to build rockets, but I wanted to know where they landed. I remember spending a lot of time. I spent a lot of time trying to figure out how can you predict what angle you should launch the rocket so it'll land in the same yard. Because I keep launching them and then scaring people 2 yards down the road with rockets landing in their yard, right? Angering more likely. Um, so yeah, I remember looking. I remember that led me to read up a bunch of things about differential equations and stuff in A levels, and then starting to realize all this crap we learned in A levels is actually useful if you want to find out where the rocket falls, right?
Right.
So then that made me want to do research of some kind. But I remember distinctly going through this process, going like, okay, I'm pretty good at maths, but I'm not good enough to really do good in maths. So maybe I'll do physics, but you have to be really good to do physics good. So I'm not good in that. So I'll do engineering, right? So, do engineering. And I remember in engineering, I wanted to do mechanical engineering. So I started university doing mechanical engineering. In the first exam, I remember taking on the geometry plan, trying to build a little structure, and go like, you know what, I don't really understand this stuff anymore. So I didn't like mechanical engineering. And then we had a lecture in, I think, second year of university. And this guy was talking about, his name was Professor Peter Rayner. I ended up doing a PhD with him. He was talking about trying to restore old audio recordings. So he had a student at the time, a guy called Saeed Vasegi, who was doing early work at that time. So this is 1986. No,
87 more.
1989, right? Around 88, whatever. Somewhere. And, CD was just coming out at that time, right? And now you had this back catalog of analog recordings to convert to digital. And people realized that the quality of those transfers were not particularly good or not always good. So restoring that material and removing the cracks and pop and missing chunks sometimes, right, became important. And so they started to work on digital signal processing techniques to do that. And I was only undergraduate at the time, didn't know about signal processing. And I remember this 50-minute lecture where he just sort of spell out roughly all this stuff works. And I remember thinking to myself, geez, so you could do maths, and I didn't have to build any circuits. I could just take the maths and write software and do something cool. So figured, right, signal processing, that's what we're going to do. And that's how I ended up doing the things that I did.
Okay, that makes me feel a lot better.
All right, good. Yeah, I don't think, very few people know what they're going to do from the get-go, right? So that chance, circumstances, and some hidden drive within yourself pushes you in the right way. You have to be lucky enough. I suppose I was lucky enough to be exposed to the right things at the right time.
Absolutely. And one of the things that caught my eye in your wiki, it says that you had a boundless curiosity, and I think you're inspired by Carl Sagan. And I think in that time, a lot of space was a big thing, right? Going to space, or just seeing a lot of that in the media. And I think that did inspire, your particular generation of engineers.
So that wiki entry just appeared a couple of years ago.
Okay.
I don't know who wrote that wiki entry. I feel like I should go in here and change a lot.
Yeah, you probably should.
Yeah, some of it kind of not quite right. So yeah, I remember Carl Sagan and David Attenborough, big influences in a lot of people's lives towards that mid-80s time, Life on Earth and Cosmos. But yeah, I suppose it's maybe that's what made me think about research as a thing you could do. But I guess the bottom line was that I was interested in taking the things that we were learning about and fascinated that you could actually take this rather esoteric mathematics and make it do something worthwhile. Right?
Yes.
So, and that's what I still do today, I guess. Yeah.
That's pretty cool. And what would you say, and at different points during the show, I'm going to ask you sort of for some advice, at least for parents, or some in the moments for parents that have kids in this new technological era, and what can they sort of do to sort of cultivate that environment of curiosity, right? If they want to go launch a rocket and throw it in the neighbor yard and the neighbor get vexed, just let them go piss off the neighbor, right?
Yeah, that's a good question. I guess there's a balance, some sort of balance you have to strike between curiosity and don't forget your studies, right?
Yes. Okay.
So yeah, I mean, I think sometimes the internet could be a bad distraction, right? And a lot of information at your fingertips, but it's not curated information. It's random stuff. And
right.
It's very difficult for parents to figure out what is good and what is not good on the internet for children to look at. And it's such a vast information resource. Is the thing that you would, you sort of gravitate towards. So I certainly encouraging children to read is a big deal, right? Read everything, get hands-on, right? Read. And I was always reading stuff, not textbooks, right? But sci-fi, fantasy, all sorts of things. And I think that's important, just to stimulate imagination and curiosity. Nothing could replace reading.
Yes. Okay.
And that's advice number one. Yeah.
Perfect. So when you were at University of Cambridge, that was probably one of the top schools in the UK at the time, right? So what was it like studying there as an undergrad, coming from Trinidad? And did you?
That was a paradigm shift in experience, right? I went to Cambridge in 1986, and in 86, they had the coolest winter that they had for about 20 years or something. So that was stinging. And I remember waking up one morning. I never saw fog before. I wake up one morning, went outside, find that I couldn't quite see, and trying to get the Yampy out there. I was telling people, no, it's still there. I can't see. And they said, that's fog. I'm like, what? Fog? That exists? So yeah, that kind of culture shock was, it took me a while to get over that. But it was a fantastic experience. I mean, hands down, right? I learned so much there, not just because the teaching is so good, but because of the people around you, it's good. I definitely get a good kick up on the backside. You think that you're doing well in school, and you go there and you realize actually everybody doing really well. So,
yeah, because now I guess you're probably one of the top students in Hillview. And then when you get to Cambridge, where would you have ranked yourself when you first came in?
Well, I think I barely passed my first year. And second year, discovering signal processing, really that motivated me to do well,
Yes.
I don't know where I would put myself at all, but I definitely wasn't in that top 10% of that class, for sure. There's so many people just better at their studies than me. The one thing that I remember, I was just always motivated by the kind of open-ended projects that you got in university and research parts of those projects, and maybe more so than my friends at the time, which pushed me towards doing a PhD and so on.
Okay.
And that's not a very tiny percentage of people who go on to do that.
Yeah, so that was actually coming up to my next question, right? You finish undergrad, and I typically label people who do PhDs as crazy people, just because it's an enduring process, right? It's not something to take lightly. And I say crazy, not being that they're actually crazy, because I did it too, right? So
I'm not so sure that you're too wrong there. Yeah, look, very few people go on to do a PhD, right?
Yes.
I try to tell my students that all the time. Most of the people you're talking to, they don't have a PhD. That doesn't mean that you're unique. That could probably mean you're just weird, right? So it might be better to start from that attitude than thinking that you're somehow special. But
right.
Yeah, PhD it's not for everybody, but I thought it was, I suppose for me, two things come together, right? I had liked this area that I discovered, with that lecture in second year, and then I did 2 internships in the third year in that lab with Professor Peter Rayner, and that really got me thinking about doing more of this. And it was at that time it's hard to get a job in that area. It was kind of newish stuff, so PhD seemed to be a good plan. Funding and so on is always a problem. Lucky enough to get sort of partial funding from some grant in the lab and so on. So yeah, I think you definitely in a different headspace when you're doing a PhD. Everybody goes through. It's funny, everybody does go through the same sort of ups and downs in their PhD, and none of my students ever believe it until they're done, right?
Yeah.
So after your first year, every PhD student always thinks they're not making progress, they're not doing anything, it's all horrible, maybe they should leave. And then they stick on with it, and after the second year, they realize, I'm making some progress here, I got a couple of papers published. And then when you reach the fourth year, about half of them going, how can I do more? Can I stay here? You know? So yeah, it's a similar cycle for a lot of people.
Very cool. So can you maybe share about how you adjusted your attitude from undergrad to go into a PhD, right? So maybe most people listening may not do a PhD, which is perfectly fine, but I think there are characteristics of that process or some mental things that you have to do that I think can serve you at any stage in your career, right?
Yeah, I guess a certain amount of independence and some, I like to tell you this song, it's like a tiny ability to see into the near future. So, when you're trying to solve maths problems, right?
Yes.
And, they ask you to prove something, okay? Actually, the way in which you go about it is like a bit of your head sort of looking at the answer from the other side. So then you can write the next line, right? And research is a bit like that, right? It's like you grasp onto a problem. You don't get upset that there is nobody who has a solution. You're kind of happy and comfortable with having a problem for which people don't really know the answer.
Okay.
And start to chip away at it. And that kind of ability, I suppose, not to be scared that there is this problem that seems to be, either a lot of people working on it without success, or there's a new problem nobody understands. The ability to say, okay, that's all right. We could break this down into smaller parts. And then every part brings some, don't be afraid to bring some sort of analytical technique to every small part, right?
Right.
So yeah, the step that I made to do the PhD was probably made before that. The fact that I had liked doing projects like the final year project. I sort of quite quickly recognized that the final year project in university doesn't have to be something that my supervisor told me to do. It just has to qualify as something researchy, which could qualify as a capstone project.
Right.
So I was working, a good friend of mine, Graham White, who he was the chair of the ACE, right, Nature Center, right? He used to talk about technology and the application of technology to things in Trinidad, and recognizing he's a bird enthusiast and so on, and recognizing bird songs and frog species was always something we used to talk about, right? And so I decided, well, why not make that into a project, right?
Okay.
So we made a whole bunch of frog recordings and then figure out, so basically doing human speech recognition technology except applied to frogs, right? And frogs are a lot simpler than people. So they're much simpler, right? So yeah, there's a long time ago, it's 89, but if you have that kind of attitude, it sort of comes out in your final year as an undergraduate, that you find that you're interested in that project just because you're curious about solving things from a different way, solving something that nobody solved before, or you're just like opening the box to see what's inside. No ulterior motive, just
just to do it.
Yeah, just some crazy curiosity, and coupled with a lack of a kind of stubbornness, right? That you don't get put off, right? It didn't work, and you don't run off and say, oh, it doesn't work, I'll go and do something else. No, you say, oh, that doesn't work, so I'll try something else. Yeah.
Interesting. Stubbornness. That's I like that word that you brought up there. So in machine learning, right? We'll keep it to machine learning. I'm sort of aligned with your definition there.
Yeah.
Be it, what are your thoughts on doing a PhD in machine learning? I think that's a big question that most people ask, right? Hey, I need a PhD to go do X, Y, and Z. I think PhDs now are very different to maybe the PhDs in your time, simply because there's so many more software libraries that abstract certain things for you. And I think I don't want to call it the quality of the PhD. I think maybe the depth or the direction of theoretical rigor is slightly different than it was before, right?
Now, well, you can't. I wouldn't say
shut me down there if I.
Everything depends, right?
Hmm.
Like doing a PhD now, I certainly doing a PhD is the route to doing research-led activities, whether in companies or in academia, right?
Cool.
Um, and to me, those jobs super interesting, right? So all my students who did PhDs, one of them, for instance, Dan Ring, he runs the R&D unit of a company called the Foundry, a post-production company. A couple of my other students, one works as a, you know, on the surface, it might say R&D engineer or developer, senior developer or something. But in fact, these guys tackling problems that they're not solvable. You know, you're trying to find a way to make the unsolvable solvable. So
Wow.
if you're motivated by doing that, a PhD is a good route to those things, right?
Yes.
Without the PhD, you you know, these days there are a lot of opportunities in doing product development and so on for companies, but I just more motivated by that kind of inception stage, right? And to be able to carry through, right? Say I have an idea for some design, and you could carry through all the way, and you kind of understand all the different stages, and that to me comes during the experience of doing a PhD. Whereas, you know, if you leave, oh, you know, you just have your first degree, you go get a job, your experience, it takes perhaps longer to get to that point where you could kind of rigorously tackle some of these more esoteric problems. And I guess I'm biased because that's the route
Yes.
that I chose, right? But that's how I see it. Another thing about doing a PhD these days, I think anyway, is a great way to get involved in a startup, a low risk way to get involved in a startup. Because especially in this area, machine learning, signal processing, and so on, a lot of the grants and research funding, quite a lot of it is geared towards getting some ideas, you know, sort of pre-startup stage, and more academics sort of interested in experimenting with that, right? So as
Okay.
a young PhD student, you know, you have a good chance to be wrapped up into one of those things, and then you don't know what can happen, right? Yeah, I don't know. Have I answered that question?
No, I think you definitely did, and I particularly didn't necessarily see the startup angle, right? And I think someone we just interviewed, Mandela Patrick, is a perfect example, right? He was a Rhodes Scholar. He just finished his PhD at Oxford in computer vision, and he pretty much got snapped up by a pretty hot startup doing video, not necessarily video processing, but computer vision for social media, right? And then
Yeah.
I think that company is going to do quite well. So that's a nice sort of end use case of that particular path.
Yeah,
So
I
quick
guess
question. Go ahead.
one other thing, so if you're interested in working in that sector of industry, like Microsoft Research or Google Research or video infrastructure team in Netflix, Facebook video infrastructure, they look at PhD, people with PhDs with more care, right? And they kind of go to all those conferences and make contact with people and so on. So that if that is a good route into those sorts of groups. Yeah.
Yep. And you need to publish in the top conferences and journals, and that's a whole different ball game, right?
Yeah.
So in 2004, you started this company, GreenParrotPictures, if I
Correct. Yeah. GreenParrotPictures.
why'd you call it Green Parrot? Is that you had parrots at
Like,
home or something, or?
yeah, something
Oh, you
like
did?
that. Yeah.
Okay. I was wondering.
Yeah. So we had green parrots flying over the house, waking you up in the morning. So green parrot, green because you could remember color, parrot because of green parrot, and pictures because that's what it does, right? So green parrot pictures. So yeah.
Very cool. And so I think as I've listened to you so far in this interview, there is a curiosity, there is a somewhat of a stubbornness to not give up on a very hard problem that you're seeing, but there's also this affinity to building things and bringing things to fruition, which those are all traits of an entrepreneur as well. So what kind of led you to start Green Parrot Pictures, and tell us that journey until you got to Google?
Well, I guess there are a lot of things that led me to do that, right? And they happen,
Okay.
as usual, these things start years before, right? When I was doing my PhD, I was surrounded by people in Cambridge who doing startups, right? Steve Young at the time had a
Hmm.
startup doing early speech recognition from Cambridge.
Mm-hmm.
Peter Rayner was involved in a audio restoration startup. I worked for that startup for a couple of months, one summer, and you know, Mike Lynch, who actually did his PhD in that lab, who was, he created a company called Autonomy that was sold to HP and so on.
Wow.
He, those guys were in that lab, and I could see, I remember thinking to myself, this signal processing stuff, actually, you could use it to do some cool products, right?
Yep.
And this sort of in my head all the time. And as I met more people around Europe in European research, um, European research grants or research projects, right? I met people from different walks of the industry, right? So you have engineers working in research groups, you have broadcasters building teams, and you see this whole ecosystem developing in late 90s, early 2000s in restoration. And by 2004, you just see so many people trying this. And I just said, well, I was consulting for a bunch of different companies at the time, and I thought, well, let's just do this ourselves and see what happens, right?
Right.
And you stop worrying about what will happen if things go wrong. I should just say, just do it. So, we had an early consulting contract to do some work for a company called Red Giant Software. And in the course of building that, other things happened. I was lucky also to have a really solid, excellent group of PhD students who had left and to finish looking around for things to do. Andrew Crawford, Damian Kelly, Francis Kelly, Hugh Denman, these guys, enthusiastic, happy to take a chance. And at the time, it was not a really well-defined thing, right? Take some successful cinema technology and maybe push it towards consumers. And yeah, all those things came together, and we decided let's try it, and never look back really. Every time I remember talking to a lot of other people who had done startups and trying to find out what is the recipe for doing well. And so having good people around you seems to be that is really important. But the only other thing I could see is that everybody who ended up doing well did so because they didn't give up.
Right.
It wasn't some magic recipe, or you do this and you talk to this guy and you do this. It's just things happen and you have to be resilient and keep going. And as long as you're surrounded by good people, somehow it'll be okay.
Somehow it'll be okay. That's good to know. So at least I know I got to do a startup, have a good team. And I think I've been spending a lot more time thinking about, what is it that makes great companies? And it's honestly, great teams, so to say, right? And great people within that organization and seeing someone driving and making sure people don't give up. So I appreciate you calling that out. So in 2007, you received the Oscar Award, right? For which I didn't really understand the true depth and importance of an Oscar Award. So it is the highest award in the film industry, given to excellence in both artistic and technical merit, which I didn't realize there was a technical component to it, which is kind of cool. So you're probably one of the few, or maybe the only person in the Caribbean to have received that award. Is that maybe correct? Incorrect?
I think so.
Think so, yeah.
Yeah, you never know. It's been a while since 2007, right?
Yeah.
So the award is actually a technical academy award.
Okay.
A science and technology award. There are two sorts of awards given by the American Motion Picture Arts and Sciences committee, right? One is
Okay.
the Oscars for artistic merit and so on. The other one is these technical awards for science and technology, right?
Okay.
And those awards are given out the week before the big artistic Oscars event. And it was a real privilege. And the three guys, I worked together with three guys from a company called The Foundry. We call it Simon Robinson and Ben Kent. And again, it's a good team, right? And the fact that they acknowledged my input was really important to me. I guess I'll always be grateful for that. And just being able to communicate with them led us to build these things
Yes.
that turned out to be so useful, and just adopted by such a wide cross section of the cinema community.
Right.
This idea of building in between frames, between existing frames, good motion estimation, good noise reduction. All that packaged up was packaged up so well by the Foundry, that by 2007, like it was in circulation for about 5-6 years before that.
Okay.
But by 2007, it's sort of recognized as a standard in the industry. So
Wow.
it's a fantastic recognition.
Yes.
Something that is once in a lifetime. Yeah.
So 7 years after you started your company, I'm just going off the timelines that I'm seeing, sort of online, you got acquired by Google, right? And I guess they pretty much snatched your team into Google. Tell us what that experience was like, and was that kind of your intention when you first started? Maybe it doesn't seem like that.
Anyway, like none of this stuff. I maybe not motivated by money or selling anything at all, right? I think it's certainly the case that if you're motivated, clearly you want to make some money, right? Great.
Sure.
But if you're motivated to sell to something else or make loads of money, you'll get a lot of disappointments, right? So it's just fortunate that we're more motivated to try and kind of break even. I want to see this technology being used in industry.
Okay.
And when Google started to talk with us, I think it's the second time I was talking to Google. Initially when they acquired YouTube in 2006, and then again in 2010 or whatever, because I suddenly realized that this technology could have impact in compression, right?
Right.
So I started to kind of demonstrate that. And, again, because of PhD and doing research, and you're in that community where you're traveling to these conferences and you meet people who would spot your papers, and so you have a kind of you have a kind of baseline
reputation,
yeah, which means your technology perhaps more credible, or
yes.
And so in 2010, 2011, when we were acquired, that was also a big surprise. It took a long time to get all that paperwork done, but it was another crazy, amazing experience. The whole team went over. And two are still there today. Andy Crawford and Damian Kelly. Yeah. One in Google Research and one in Search.
One in Search. Okay.
And so myself, I'm back here, and Hugh Denman is back here as of 2016 or 2015 or something. But those years, really educational. I really opened my eyes to what it takes to roll out something, relatively simple in a cinema scale to 200 million people or something, right? Simple things become really complicated when somebody is trying to use your application, I don't know, several million times every hour or something. So every addition is looked at very carefully, right? So I learned a lot, make a lot of contacts there, and it actually caused me to recognize inside the video infrastructure world was emerging a whole bunch of new problems that were as much research problems as industry problems.
Yes.
And we started also building a kind of is a kind of skunkworks research team inside YouTube,
Yeah,
which is now the media infrastructure team,
that's
run
cool.
by a guy called Balu Adsmili, and we still do some work for them, or work with them.
Mm-hmm.
Yeah, so what can I say about working inside there? Google is many ways like a university, you know,
Huh.
in the sense that at the time anyway, things changed, I guess,
Yes.
since 2016, right? At the time anyway, you were, you know, it was easy to go and talk to people in different groups. Quite quickly, I got to know a lot of people around different. Anytime people were processing pictures, somehow we would find out about them and talk to them about technology and so on. And that's kind of fun and refreshing, right?
Yes.
The things that I suppose, you know, it still work, right? You still have to make your stuff work. So you have to get more involved in the debugging of code and so on.
Mm-hmm.
GreenParrot had a bunch of tools that would work for several hundred people. But, you know, like I say,
Not
it's
several
still
100 million or
it's a
billion now, right?
whole other story. Yeah, yeah. So yeah, it was good. I was glad that Google didn't stop my interaction with university either. So while I was with Google, I was actually still doing a course remotely from Google
Oh, wow.
here in Trinity for all those years I was there. And, you know, still had a couple of PhD students here and so on. And eventually, you know, people realized the value of that.
What would
Yeah.
you say to people listening about as they think of technical careers, let's say, right? What can they do to, let's say, prepare their mind to adjust to scale? Because I think maybe in the Caribbean, you mightn't be thinking a lot about scale, but that does not necessarily mean you can't launch an application from the Caribbean region, let's say, that does scale to hundreds of millions of people sort of globally, right? Any thoughts there?
How to build an application that will scale.
Not necessarily build an application, but you know, what are things that what are patterns of thought, let's say, right? So for instance, you know, you might read a paper and you see this particular algorithm and you say, okay, yeah, this seems simple enough. But then once you go to scale it, it's a whole other beast, right? Maybe just things to read or make sure you understand really well.
Yeah. All right, the cost of computation is a significant thing to pay attention to. So, you know, yes, you could make things run in real time, but at what cost? And do you have the resources available where you think you want to run that application? So let's say you're trying to build something in your phone. What resources do you think you have available on the phone? And trying to realize that when you're actually trying to build these applications, and the phone is a nice example, people want to do a bunch of different things on their phone at the same time, right? They want to take a call, and you might be, you know, chatting with somebody, and you're watching YouTube or something. So you can't pretend that, yes, it's a, I don't know, 1 gig core with, you know, 6 CPUs. So I'm going to use the whole thing to run my video processing algorithm. Nobody would like you if you did that. So trying to pay attention to the compute requirements and resources and trying to figure that out. And the other thing too is, you know, everybody talks about cloud computing, but you have to kind of pay attention to what bits should be there and what bits should be on your phone. Where should the different bits be, right?
Location of data, essentially,
the location of data compared to where your processing engine is, and you know, can you do? You know, they have this thing about edge computing now, which is a kind of repackaging of the old idea of bringing your data close to your processing. Right, in the days of mainframe, that's you're thinking about that all the time, right? So yeah, also. I suppose as you scale, as things get more and more popular, more and more of your process is worth thinking about hardware designs, right? And so,
interesting.
You see Facebook and Google, everybody moved their portion of their video coding into hardware to keep up with demand, yes, but also to reduce energy consumption. So as things scale, energy consumption becomes significant, right?
Yes. So I guess for people maybe studying or in those careers, it's not only about probably the software that you work on, it's the underlying hardware and how that scales and consumes energy and how much it
And
costs.
maybe another thing to think about too is the maintainability of your software, which is not something I thought about much until working with YouTube and the infrastructure team there. Why choose one framework over the other? Why stick with general purpose computing when you could do everything in CUDA or something, right? It's because you need to be careful that the software that you write is readable in 5 years' time, maintainable by a bunch of people. If it all goes down and 1 million people sending you emails or something, you must be able to find the root of the problem and, respond quickly. But I suppose all these things that's just great problems to have, right? If you're operating in a space where all these things are really a problem, you probably win already. So.
That makes sense. So you're back at Trinity now after Google. You have all the, I would call it the administrative duties in addition to the academic explorations, and you spent most of your career in this video space, right? And now that encompasses computer vision, and then I think if you look maybe forward, there's this whole notion of the metaverse thing, right? So I'm going to throw some buzzwords at you. Let's call it. What would you say to people listening? You've seen the evolution of video, which I don't think many people would have been privy to, especially you've seen it in the film industry. You've probably seen it across different dimensions of film. Then you saw videos getting scaled out. You spoke about coming over the top when it came to streaming media without, let's say, cable providers. What do you kind of think is the next paradigm shift that people should be paying attention to?
Yeah, well, everybody always asks that. That's an important question, when it comes to video broadcast, right? I guess in 2006, when YouTube got acquired by Google, right? People could see that video over the internet was the next big thing, right?
Yeah.
But it was only when Vimeo started to stream HD that everybody realized, actually, because at first the video on YouTube wasn't as good as what you get on TV, right?
Okay.
But then once people started to show, you could broadcast HD over the internet too, then you start to overtake TV, right? And in 2015, something really interesting happened in 2015, and I don't know if anybody really noticed. In 2015, you were able to get high dynamic range pictures and 4K from YouTube and Netflix before you could get it
from cable.
And satellite and cable.
Wow.
Right? And it was about a year, maybe more, before everybody else caught up, right? So from that point on, what's been happening is that these companies able to take advantage of the technology in your television set before these other traditional broadcasters. And there are a bunch of historical reasons for that. But the television technology, there was a big shift in 2014, 15, right? The depth of color, and of course resolution, frame rate, sure. But the depth of color, I think, is still being explored, right?
Really?
High dynamic range pictures has a lot more to go. But I know we have these new things that people are trying. So VR, 360 video, interesting, but not really a mainstream medium. It is more maybe for surveillance and so on. Every, 25 years or something, stereoscopic 3D television comes back, in different incarnations. So that's to come again in a new incarnation. But I guess VR VR is a lot of people experimenting with what is possible with VR, but I think what's interesting is the cinema production world, they're not so keen on VR anymore. And
Really?
yeah, VR seems to be more of a niche application and super for training. If you on site trying to figure out how to fix a blowing up oil well or something, you can put on your headset and get the ideal relationships between things and then go and do it, right? But I tell you, what I think is really important for the future is what we're doing right now, right? Real time streaming, remote production, that sort of thing. The quality of the stream is still not as good as the quality of the sort of offline stream that you could get from Netflix and YouTube, right? So, and the better quality real-time communications gets, the more important it'll become. I mean, people underestimate, well, maybe not now, but had the pandemic hit 7 years ago, right? This stuff was still,
we've gone through.
It was tricky, right?
Yeah.
Thankfully, the technology was ready at the right time, and the pandemic just made everybody realize, we should pay more attention to real-time streaming, right?
Wow.
But the real-time streaming applications have come along a huge way even in the last year and a half. I'd expect that to continue and catch up with, kind of cinema or offline broadcast quality, right? It's still got a way to go, right? I mean, your face is kind of plastered out, the texture not really there.
That's probably a good thing, boy. I know.
So it got a way to go in that technology. Another big technology we're paying attention to is augmented reality. So you can see a simple version of that in the sort of more upmarket cars, vehicles, right? So you can see, displays, sort of active, I call it active displays, head-up displays, right? So they superimpose on the road directions as you navigate and so on, so you don't have to look away from the road. That sort of simple application in the car environment, you'll see more and more of that kind of thing.
Coming out everywhere.
Yeah, and AR, that technology has a lot to go. Yeah.
Cool. I'm gonna try a little spin ball. So get ready for this one. So you shared your passion for cricket, right? So kind of tell the audience about, in your mind, the importance of cricket and share your love, and then I'll ask the actual video-based question about cricket.
Cricket. So I guess I exposed to cricket all my life, right? My dad was a very keen cricketer, and here now I run the university social staff cricket team, right?
Cool.
And that's just a lot of fun, right? To me, cricket, I suppose, like many sports, bring people together. And because of cricket, I'm playing cricket here, that I know so many people from outside my department, right? So my people from zoology, history of art, chemistry, and funny enough, managed to do research projects with all these people, right? Because they all have to do something with a picture. So
yes.
So cricket to me is more than just the sport, right? It's about meeting people.
Wow.
And also, especially, home. What is home to me, right? After all of these years, a big part of me still in Trinidad, even though I live outside Trinidad for most of my life, right?
And your accent's so strong.
Apparently, people say that. Yeah. So cricket is also maybe a way to keep me connected in some way.
Right.
And it's about meeting people and about keeping active and so on. There's a lucky that I can still be playing cricket.
Yes.
Here in Trinity on a fabulous cricket ground, about 50 meters from my office. That's great.
Oh, that's beautiful. That's the dream. That is why I went back to Trinity College.
That's why I went back. That's cricket. Nothing else. Just the cricket. Yeah.
Good to know. So the question, the video-based question, as we get a little closer to the end, NFTs are a big thing now, right? And capturing. I think that's a very interesting notion of capturing a particular moment and then someone owning that digital moment. Based on your background, right? There's a certain quality of that imagery that needs to exist, and based on what I've been listening to you throughout this interview, there is more. There's more depth to the capturing of reality that still has to come in technology. So just share any thoughts that you have on maybe NFTs and maybe its role in cricket. Someone did tell me that.
Yeah, I don't know that much about NFTs.
Okay, sure.
Kind of a bit strange, actually, that somebody could own something so ethereal, right? But yeah, as far as you hit the nail on the head there, capturing the moment, right? That's what video and audio production is all about, right? To immerse you in a moment, right? And there is so much more that people want to do. I mean, for instance, we know one of the big differences between a cinema screen and this 24-inch monitor in front of me is that even though the picture on both of those things is the same rectangular picture, the cinema screen will occupy more of my field of view than this thing. And automatically, when you do that, forget about VR or anything. As soon as you do that, you're more immersed in what you see, right? So that search for trying to displace you or teleport you, right, into this alternative world where all your senses occupied with this synthesized version of the world is the holy grail for media production and capturing, right?
Understood.
So you can see everything is going in that direction. So more bit depth, better colors, a higher resolution, and higher frame rates, 360 video, VR, and so on. And I tell you the connection with cricket, right? So there's a lot of these technologies are not taken advantage of in cricket yet, right?
Okay.
It's probably second sport to use the kind of Hawkeye trajectory prediction thing, but you could see things like head-up displays for umpires would be just amazing, right? So the umpire has a little visor, and the kit that he is using connected to some kit back in the pavilion, and as the umpire looking at the field, he could see all the ball maps of all the players and all the trajectories of the last ball, and that'll totally change how powerful the umpire is in the game, right?
Wow.
Even for spectators, right? You could let them experience that kind of information if they want in their own head-up displays around the ground, and that could be quite cool.
That's a new depth of experience coming, or could come. I mean, essentially.
All these other things on the agenda, right? Right now, we are trying to look at new technologies for sports streaming to make it easier to broadcast. Like the game that I played last Sunday, right? Nobody broadcasting that. Nobody wanted. It's just a bunch of social cricketers, right? But what if it was easy to broadcast that?
Why not?
What if I could put a trackpad on one part of the screen on the field and just have it on, and there is a bit of machine learning inside that knows, how to track the interesting parts of the ground. So maybe you have a big view of the ground and you pull out different bits and you broadcast that. If that exists suddenly, you will get a small audience, right? Maybe people around the world will tune into that. And, you have several thousand games going on at any one time. So a whole new audience, right?
That's a cool. I like that you brought that up. I think that might give many sports people around the world different opportunities, right? So it's very similar to, let's say, the streaming where, each streamer has their own little audience. Maybe your team might have a little audience, and you know what I mean?
Yeah, exactly. Yeah. You're just trying to, and you're making it. This is where the machine learning part comes in, right? So in the last 5 years, there is this algorithm. You only look once. YOLO.
Yeah, YOLO.
Everybody knows about it, right? And it kind of blew wide open this whole area of video object detection and tracking, right?
Mm-hmm.
Much more than before. And it really changing what you could do in sports scenarios.
I see.
So yeah, we're trying to look at how we could use those, let's call them black box technologies, in imaginative ways to kind of inspire new productions. Yeah.
Understood. So as we get to the last segment of the show, we've explored your career journey. You shared certain things with us in terms of attitude and maybe being very passionate kind of about what you do. But around the passion portion, right? This consider this part of the interview, the advice portion. I've heard different things where, okay, so you should follow your passion. I've also heard paradigms where it actually takes you some time to get good at something, and then you end up becoming passionate about it. So can you share with us, through your experience, what has resonated for you?
Yeah, well, that's a good way to put it. It takes time. Things take time. Right? It takes time to get good at something. So yeah, I could do things now that I could do 10 years ago. I look at somebody brings a video problem to me, I could suggest solutions that it wouldn't have been possible even 10 years ago, right?
Wow.
With the breadth of experience that you have over the years. Patience, important. I just kind of stubbornness. I remember my supervisor, PhD supervisor, in my second year. No, at the end of my first year of PhD, he told me, Kokaram, your math's horrible. You better fix it. And he was right, The thing is, I just couldn't get motivated by mathematics, right? What motivated me is sort of the application. What you're trying to do, and then you get kind of absorbed in the solution, and then you find this crazy little bit of mathematics that you then go and you spin out or fix or something, right? And then I really started to take that bit of what I was missing more seriously, right? Because at that time, I used to be frustrated that I couldn't, I wasn't good enough to figure out some of these more tricky mathematical models. And then I just had to have the patience to spend time. I tell my own students, just take the paper, which is portrait, turn it landscape, write every single thing out, right? Don't skip a step, just write it out. That helped me a lot. So just having the patience, don't mind being slow over things, just get to the end eventually. That, to me, that's important.
Understood.
Another thing that's important over the years I realized is, pay attention to people, pay attention to people. Everybody has some contribution to make. Leave yourself open to opportunities. When people come to you with, maybe they talk like in a cricket game, right? Happening all the time. People, years ago, I was playing cricket in Cambridge. I used to play for the engineering department. And one of these guys, his name was Neil Armstrong, as it turns out. He was talking to me about a problem they had with tracking fluids in a combustion chamber. Right? And, it's an interesting problem, really hard. And, you could go two ways with that. Oh, too hard. I doing my PhD, it's a big distraction. Okay, certainly is a big distraction, but, after a few chats, you look at some pictures, try to come up with some ideas, and it lead to a whole other little thing I was doing on the side, with dimer bends and all sort of stuff. So kind of leave yourself open, talk to people. Problems that seem kind of off-piste turn out not to be off-piste. Right? So.
Wow. That's a good, yeah, I appreciate you sort of bringing that up. And I think the next question is very similar to what you just shared. And I'd ask you to maybe summarize it in terms of what two pieces of advice would you give to a high schooler, someone in college, and a professional, given your experience?
High schooler. high schooler and college professional. Was it few people? High school is like
High schooler, college, and then an actual professional working.
So high schooler, well, maths, physics, very important.
Mm-hmm.
Keep yourself interested in new things, right? I felt reading was a really important thing for me, just to keep yourself curious and imaginative. Right? And for a university student, you gotta leave yourself open to interesting things to happen, right? So your experiences in university will be with you for the rest of your life. The people you meet there will be with you for a long time. I found that maybe the biggest informative thing, if I think about career-wise, the internships that I did in the same university, right? I did internships in research labs in Cambridge, right? Those helped me a lot to kind of put what I was learning in context, because I really had a problem doing some of the work without context. And not every lecture will give you that sort of application context or the research context, right? Just be saying, see, this is an equation, do the Laplace transform, God bless you, right? But by doing these internships, right, I could see how these things are important and could lead to interesting career. So that inspired me a lot. I was lucky enough to have a good bunch of friends, more at the PhD level, I would say. People I still talk to today. And that was important. Sharing problems.
Sharing problems.
I don't know if maybe we're lucky to have a group of, 15, 20 PhD students who felt pretty at ease with each other and able to share problems. And as soon as you realize you're going through the same thing as other people, things are a lot easier, right? And like that problem in mathematics, for instance, is because they're talking to each other about their PhD, and people can spot, I could use that idea over here. So I use it here, and we do a joint paper and that kind of stuff. Keep things interesting, right?
Yes.
What was the last?
And professionals, what would you say to professionals? They think they made it, but there's always room to grow.
Yeah, I mean, sure. See, right now there's a lot of opportunity for trying to keep your knowledge current and so on. In the video industry right now, you have this kind of interesting space of engineers between academia and the research labs and industry, kind of application space where there are interesting new problems, which those guys don't necessarily realize is the tip of something bigger. But there's a lot of food for thought there. So DMUX is a good example. DMUX is a yearly video engineering conference where people talk about video infrastructure problems. And inside there, always a really interesting take on the problems facing video infrastructure today, and what you can have an academic perspective or kind of research lab perspective. So these little conferences, I think, is important as a professional to kind of go to some of these events, right? DMUX happened to be online this year. You also have International Conference on Image Processing, CVPR, I think everybody goes to right now, but also the broadcast conferences, NAB, IBC, and so on. That sort of glue stuff helps, keep you aware of what's going on, and in maybe a less painful way than reading newsletters and so on. Because just walking around, meeting people, hearing what they have to say, and seeing a couple of talks inspires you to push your group further, or to look at some new emerging technology before others have made.
Understood. Yeah, I appreciate you calling that out. So the last, I would say, 2 questions or 3 questions. One of the main reasons we do the show is to encourage people from the Caribbean to pursue these type of data-driven careers, right? So what would you say in your Caribbean heritage gave you different components for you to be successful? Is there anything that you can maybe pull out? I think maybe the love for cricket did make you sort of a easy person to probably talk to on the pitch.
Yeah, maybe.
West Indies,
I was lucky to have good teachers.
Lucky to have good teachers. Okay.
Yeah, teachers, who somehow bring out or encourage curiosity.
Mm-hmm.
My parents always used to happy to indulge my crazy requirement for large amounts of novels. So that was also a good thing, just reading. And I guess being lucky to have the right teachers, and that's not within everybody's power.
Yes.
Reading a lot. And in the Caribbean, I mean, everybody kind of by default has a easy social way about them compared to other around the world, right? So
yeah,
that makes me sort of, I guess, it different, right? So I kind of stand out when I talk in a conference. I remember actually the first talk I gave in our research conference, right? The back row was laughing, and that put me off because I was first year PhD student, right? And afterwards, I was asking them, they say they couldn't take me seriously because of the accent, right? And all right, you could get pretty pissed off with that, but then I remember afterwards realizing, well, they'll never forget me though. So
yes,
they'll never forget what I said, and I think that's probably why I didn't lose the accent. It's unique, and you have a background that helps you work with people. I think that's important.
Absolutely. So well, we'll do this one first, right? What are 3 books that you recommend? I see you put some serious ones here.
I was putting some serious stuff there, and I don't know if that's where you wanted to go there, but
well,
3 books I recommend, right?
Yeah.
All right. If you want to learn about the heart of machine learning, right? There's a book called Numerical Bayesian Methods Applied to Signal Processing.
That's sounding hard already.
That's not hard, right? But actually, that book written by a guy called Joe Rooney and Bill Fitzgerald, is a pretty important text.
Okay.
And if you want a kind of nice background text that helps you again see into machine learning, but not too painful, a book called Decision Estimation and Classification by Charles Terrian.
Yep.
But if you're looking for entertainment, loads of things by David Gemmell and Ian Banks. Fearsome Engine. I like a guy called David Gemmell wrote a series of books. What do you call it? Heroic fiction. Yeah.
Okay.
Pick up any one of those. Waylander is a good one. I just can't remember the others right now.
Cool. Well, Professor Kokaram, I really appreciate your time. You did share a lot with us today, and I've personally learned a lot and have gotten a much deeper appreciation as to the fact that we could have this call, and you're in where you are and I am where I am. And yeah, any parting, words of advice for the folks on the call? You've dropped a lot of serious ones there so far.
I would say my parting advice: have patience. Stick to it. Don't get too religious about sticking to it, but stick to it, and pay attention to people.
Pay attention to people. Absolutely. We appreciate your time, and we'll talk again soon. Take care.
Thanks a lot, Mark. Take care.
Bye. I hope you enjoyed today's interview with Professor Kokaram, and you took away some great perspectives for your own journey in machine learning and tech. Do your best to cultivate that spirit of resilience when tackling new problems. It's really going to work out for you in the end. The field of tech, machine learning, and AI will have a great impact on the Caribbean region, so make sure you're involved. Remember that your Caribbean heritage is a great asset for your professional career, So take advantage of it and keep working on your skills. Later.